This is the second lesson about encryption. In this lesson, we will talk about the ciphers embedded with Python, the ready algorithm used for encryption that included in Python itself, or included the library bycryptography and bycryptodome. First, we should know that there's two main categories for encryption according to the key used in the encryption. And we said before that key is indicate for the password that used to convert the human reading text to unknown text that human can't understand. So the two main categories of encryption according to the key is symmetric key and asymmetric key. And in the symmetric key, the data is encrypted, which is transformed from the known form to unknown form using the same key. So the key used to encryption, like opening the door, is the same key using to decrypt, like closing the door. So the same key is used for the two processes. But in the asymmetric key, this is a more safety standard for encryption, which use two keys. A key for encryption called the public key, and a key for decryption called the private key. And private key used for decryption. Okay. First, the examples that we will talk, or the ciphers that we will talk about in the symmetric key is Fernet and another cipher called AES, or it's typed by letters, capital letter AES. This cipher has symmetric key, which is the same key used in encryption and decryption. And the cipher we will study in asymmetric is only one cipher, is RSA. By the way, there is a lot of ciphers in symmetric and asymmetric key. And most of the websites exist in the internet used the encryption system RSA, using two key encryption and decryption. And also there is a website using AES. Those two types is difficult to encrypt because the long or the length of the word or the password used in encryption is very long. First, in this lesson, let's talk about the first type of encryption, symmetric key, using Fernet. So here we will talk about Fernet. Okay. Just wait. How to encrypt a file using the Fernet. The step number one is to generate a key to encryption. The second step is to use encrypt or decrypt Let's see an example. First, we should import our library Fernet from cryptography.fernet import Fernet. Then we need to do the first step, which is generating the key. So the key is Fernet dot generate key. Let's type here example, and make a comment to know what the steps. Here is the step of key generation. Generating. The second step is use the encryption or decryption method. Here we have the text. This text, for example, is Facebook. And we want to encrypt this text and print it out in the editor. First step, we generate the key. Second step, we use an encryption or decryption method. How this happen? We should type the encrypted text, the text after encryption equal the key, which is Fernet dot or Fernet of key. Okay. Here dot encrypt, and we pass the text here. Here is the text, but you will notice that this text is a string, and we should converting it to a byte using decode function, using encode function. Encode used in the encryption, and we will print the text to see the text after encryption. Let's run. Here is the text. You will notice that this is the text. Let's see it in the editor. Let's make this bigger. You will notice this is the text of the encryption. Here is the text. Start from B, which means binary, ending with this single semicolon, single colon. If we wanted to know the length of the text, just use print and length of text or encrypted text. This. Here you will know, or you will notice that the length of the text is 100 letters, and this text, this Facebook word, is transformed to this text, which is unknown by the user. If you want to decrypt this text, you just use the same method here, and we will rename this decryption or decrypted text. Using the same key, and transform this function to decrypt. Okay, and instead of encode, you replace this to decode. to eliminate this B and single column character. So you should use decode. Here is an error. What is the error? Unexpected, comma, where is this comma? Yes. Unexpected. Okay. Has decode. Let's eliminate this decode. And we should here type the encrypted text, not the text itself. I'm sorry. Here is the text, encrypted text. Okay. Dot format. Token must be byte. Okay. The text you decrypt must be byte. Let's do this. Here is the text. We not print the output text. We will print the decrypted, and you will see Facebook again. Here is the Facebook. So after converting the text to decrypted, you should make here decode. Here the word we encrypted. Facebook encrypted using this function to encryption text. Then we decrypt using this function, and decoding, you will get the origin text. By this way, you do an encryption and decryption using Fernet. We call the library, we generate key, we take the text and put it in this function, which is the key of Fernet.encrypt the text encoded. Because Fernet don't encrypt the original text, it encrypts the text after encoded. Let's see, there is an error because it encrypts text after encoded. And here we will take the encoded text, which is byte, and convert it and decrypt it, then converting to decode to see the origin text. As you see, by this we have reached to the end of the lesson. Let's meet in the next lessons.